I can't really name anyone that has so much integrity as she does to the things that she's accomplishing. It's pretty amazing. Having Claire as a role model, just a strong woman in science and just so smart and so kind. It's just a huge confidence booster. Is that, hey, I could do that too, you know? That's possible, that's successful, that's what I want to do.
I would characterize her as a pioneer in the field.
The amount and quality of the work she's put out is second to none.
I know people who have a lot of tenacity. I know people that have integrity, but it's rare that people have both together in that, you know, that combination that Claire does.
Every morning, Dr. Claire Parkinson gets up before sunrise and runs 2 miles to work. She hasn't missed a day in nearly 40 years. To know the evolution of sea ice and how we observe it from space is to know Claire. This year, she's celebrating 40 years at NASA.
When I arrived at Goddard, which was in July of 1978, it was an incredibly exciting period here. Satellites were pretty new, but a lot of data had been collected.
NASA scientists were inundated with information, and Claire was in a cohort looking at sea ice, trying to make sense of a jumble of very raw, very new data. It was around that time that Claire and her team, at the time led by Dr. Jay Zwally, created the principal sea ice record that we use today. How does something like that record help you do your job?
Oh, that record is fundamental to understanding sea ice. So without it, we wouldn't know how rapidly it's changing.
You may not realize it, but Claire's work studying the changing extent of the ice caps deeply affected our understanding of climate change, and relatedly, our understanding of how climate change affects life on Earth.
One of the clearest signals for climate change that resonates with people has been this shrinking of the polar ice cap in the summer that we're able to see because of Claire's work.
After we had a record that was about 15-20 years long, we started noticing that the extent of the ice in the Arctic was getting smaller over time.
Sea ice is formed on the surface of the ocean, and therefore is made from seawater. The biggest concentration is in the Arctic, and it's also where the biggest loss in sea ice is occurring. Every year, NASA reports on the sea ice minimum and maximum extents. As expected, the data is concerning.
By now, not only has this trend toward lesser ice continued, but it's even accelerated, so that now the decreases are greater than what they had been.
These trends are deeply troubling. But one thing's for sure. Our awareness of shrinking sea ice extent due to climate change was propelled faster and further after Claire Parkinson arrived at NASA.
I mean, she takes her job seriously, and the health and welfare of those instruments in space, yeah, she's on it. You know, it's one of the things you don't worry about because Claire's in the loop on these things. It's going to be fine.
In science, we stand on the shoulders of giants, on the shoulders of those who explored before us. But then, some among us are giants.
For
us scientists, it's incredibly exciting to be studying these glaciers and ice sheets right now because they're doing something that hasn't happened in thousands of years. We're watching changes take place that haven't happened since the end of the last ice age.